Okay, so now so far these things are okay. Now I need to change it a little bit. This is not enough for me, because the problem is this omega, xi and omega are constant values, and you know that for this thing, for your response spectra, you need to change omega n constantly, and maybe xi also. So these values should be into my this value should be supplied by us. This should not be directly included into this function. So this derivative function should be parameterized somehow. So let us do that. First, let us say input xi and input omega n. So these two, whatever additional input I wanted, I have added it here, xi and omega n. I will use that here. Instead of that value, I will use xi and omega n, and here also xi. So far this is okay. The problem is now, if I execute this, it will show me error. And what is the error? The error will be because of LSODE. Because see, in LSODE we are going to give only this SDF ODE as a name of this function, and by default if you give LSODE, it will accept only these two as inputs. It will not accept anything beyond that, and then it will give you error, that it will tell that what is this I don't know, what is this I don't know, and that will be error. So just to avoid that, we need to make one small addition into it, and that is we have to add another small function. Let us call that function as g is equal to, and the syntax is something like this, at u comma t. This can be anything, SDF ODE and u comma t comma xi comma omega n. And now to this LSODE, instead of giving SDF ODE, just give this g function, this new function. So what we did here, or what are these statements mean? First of all, let us check this. See, LSODE accepts only a function name. So that function name, and that function has to be function of only two variables, u and t. Okay, so this can be x and t as well. It doesn't matter what it is. Only I have to keep it consistent. Okay, so this function accepts only two inputs. So now g accepts only two inputs, x and t. That is not a problem at all. LSODE. What happens at g is equal to x, at x t? When the core goes here, x, this value is replaced here, this value is replaced here. But SDF ODE needs two more variables. So these two variables are defined here, xi and omega n. If suppose I give, let us say for example, SDF ODE here, what will happen is, it will directly go to SDF ODE here and check. But what happens? It has 4 inputs. But LSODE cannot take that. LSODE says that I need only 2 inputs. Give me only 2 inputs. So that's why we are masking this function into another function, where this function has only 2 inputs, and this other two functions, other 2 inputs are automatically taken from the global scope. So now if you see the g that we are supplying here, this g has only 2 inputs. So there is no problem to that function at all. And there is no problem for the LSODE as well. So LSODE can take this and it can complete the calculation. Any issue with this?
Sir, the function name, is it necessary that we should be inverted commas inside LSODE?
Not necessary. Not necessary actually.
Okay.
Anything else, huh?
Sir, and the plus n naught which were given, then in that we have to take UG from that V2A file.
Exactly. Yeah, that's what that one thing I also received a mail, so I will be discussing that. But so far everything is okay.
Do we have to use only that variable, that variable that then SDF definitely you have used,
So
we use the in function they use it for SDF. So they will use the capital U, right? So do we have to use that same variable capital U and use added variable?
Here you can use anything. That's why I changed it to X, so that it should not be any confusion. So this X and this Y, just use same over here, and that same should be over here. Same in the sense sequence. It doesn't matter what the variable name is there. That it doesn't matter. Only sequence matters here. Okay. So far these things are okay. I'll just shift this to above. Yeah, and now see, for response spectra you need to perform this. This is only for one xi and omega n, isn't it? You need to perform this for multiple xi and omega n. So how will you do that? You can use just for loop, that's it. So xi, if suppose xi you don't want to change, you can keep it outside of for loop, and then you can use like for I is equal to whatever 1 2, let us say 100 values you want to take. So for each case you just supply omega n. Omega n is equal to I into 0.1, let us say. So that means it will start with 0.1 and end with 10, and then time vector will remain as it is, g as it is, u as it is, and here end for. Okay, but here what is happening is it will calculate all these u vectors, but those will be replaced. I need to, so if I want to find out response spectra, what I need here, this solution I don't want. Entire solution is of no use to me. I need what I need from this. All the values are not necessary. For response spectra, what we get, what we try maximum. Correct. So maximum values we need to get. So how to get maximum value? I think the max is the function here, max u, and if I want displacement I can choose 1. So that is u all row first column. So that is displacement column and maximum of that. But I don't want maximum with sign. I want maximum absolute value. So I need to first make absolute of it and then take its maximum, and this value I can store in something like u max is equal to u max, let us say r, and then u max I, this will at I equal to 1, u max 1 will be the first, that is for omega n equal to 0.1 and so on. So this will store all the values, and then you can plot later on with whatever variables you want here, omega n and u max. Got it?
Sir, one thing here my mind got cut. U max, why you are saying U max?
U max we need because we want to plot response spectra, isn't it? So for response spectra, we don't need entire time history. We need only maximum value. Yeah, they will be overwritten.
Yes, sir. I will just like if second value will come, then first will be overwritten.
Correct. So let these values override, because these values you don't need. That's why I have written only umax I. So now here what will happen is I is variable here. So for first loop it will be umax 1, then umax 2, umax 3, umax 4. So this value will not be overwritten. It will keep adding. So let us, if suppose I choose 1 to 10 and execute it, is it because of for loop? Let us check. No. Ignoring imaginary part returned from user defined function. Okay, some input value is wrong somewhere, because imaginary. This I. Okay, I removed that for loop, so here it should be 1.0. Okay. Now it is okay. Okay, fine. So you see here that error was because of this I imaginary number, that was taking it as imaginary number. Anyway, so now here umax, if you umax, what happened? Now you see umax has 10 values. Each value of umax is not going to be overwritten over here, because umax I, it's going to be a vector, so ith value will be supplied over there. Anyway, so this is how you have to write the code. Now there are few more changes that you will need. Moreover, this UG double dot, you need, I think you will need to spend some time on how to get that as input.